Right now, 700 light years away, one of the most watched stars in the universe is doing something that shouldn't be possible. It's spinning too fast. It has a secret companion. It once mysteriously went dark and nobody could explain it. And somewhere beneath its boiling, churning surface, a clock is ticking toward the most violent explosion our galaxy will produce in centuries. That star is Betelgeuse. And the more we study it, the stranger it gets. Let's start with scale, because nothing about Betelgeuse makes sense without it. If you dropped Betelgeuse into the center of our solar system, its surface would stretch past Mars, past the asteroid belt, and nearly reach Jupiter. Our entire inner solar system, Mercury, Venus, Earth, Mars, all of it, swallowed whole. A beam of light would take over an hour to travel from one side of Betelgeuse to the other. Compare that to our Sun, where that journey takes under 5 seconds. Yet for all its size, Betelgeuse is relatively light, only around 16 to 19 times the mass of our Sun. That means its average density is almost nothing. The surface gravity is so weak that material is constantly escaping, billowing outward as enormous plumes of gas and dust. Some of those plumes are larger than the distance between Earth and the Sun. The whole star is perpetually leaking itself into space. Stars like Betelgeuse are called red supergiants, and they're essentially stars on borrowed time. Betelgeuse has been burning through its fuel for roughly 10 million years, a blink in cosmic time, and it's nearly spent. Deep in its core, it's working through a sequence of increasingly heavier elements. Hydrogen gave way to helium, helium to carbon, and now it's fusing oxygen, neon, and approaching the point of no return, iron. Iron is where the music stops. You can't extract energy by fusing iron. When an iron core builds up in a star like Betelgeuse, no amount of fusion pressure can hold back gravity. The core collapses in under a second. A neutron star or black hole forms at the center, and everything outside, hundreds of quadrillions of tons of stellar material, gets violently ejected outward in a shockwave we call a core collapse supernova. The energy released in that single moment is roughly equivalent to what our Sun will emit over its entire 10 billion year lifetime, all of it at once. When it happens, Betelgeuse will briefly outshine every other star in our sky, visible in daylight, casting shadows at night. For weeks or months, the shoulder of Orion will blaze like a second moon. Then, slowly, it will fade, leaving behind a glowing cloud of debris and possibly a dense spinning neutron star at the center. The question astronomers have spent decades wrestling with: when? The honest answer is we don't know, and Betelgeuse keeps making that uncertainty worse. The star doesn't shine at a steady brightness, it pulses. It has a well-known approximately 400-day cycle where it dims and brightens rhythmically, driven by internal pulsations. But layered on top of that is a longer, stranger pattern, a cycle of roughly 2,100 days, nearly 6 years, where the star dims significantly and then recovers. For a long time, astronomers couldn't explain the longer cycle. Then, in late 2019, Betelgeuse escalated things dramatically. It dimmed by about 2/3 of its normal brightness over just a few weeks. This wasn't a subtle fluctuation, it was unprecedented. Betelgeuse dropped so far it fell out of the top 20 brightest stars in the sky. Headlines around the world asked the same question: was Betelgeuse about to explode? It wasn't, but the real explanation turned out to be just as fascinating. Data from the Hubble Space Telescope revealed that in September 2019, months before the visible dimming began, Betelgeuse had ejected a colossal burst of plasma from its southern hemisphere. A mass of superheated material the size of several Earths shot outward into space. As it traveled away from the star, it cooled, and as it cooled, it condensed into a thick cloud of dark dust that drifted directly across our line of sight, blocking much of the star's visible light. Betelgeuse hadn't dimmed, we were looking through a curtain of its own debris. By April 2020, the dust had dispersed and Betelgeuse returned to normal. But it didn't stop there. By April 2023, it had brightened to the highest recorded level in decades, reaching a magnitude of around 0.1, before dimming again through 2024. The star wasn't calming down, it was acting out. And then came the discovery that changed everything. Astronomers had long suspected that Betelgeuse's mysterious 2,100-day cycle wasn't a pulsation at all. It was a gravitational fingerprint. Something was orbiting the star. In 2024, two independent research groups published separate analyses of decades of archival data, photometric records, radial velocity measurements, positional drift, and both reached the same conclusion. A hidden companion star was the most logical explanation. The math was compelling. Betelgeuse appeared to wobble, very slightly, very slowly, in a pattern that repeated on exactly that 6-year cycle. The kind of wobble you'd expect from another gravitational body tugging on it from close range. But finding that body was another problem entirely. Betelgeuse is blindingly bright, and any companion would be thousands of times fainter. The Hubble Space Telescope tried. The Chandra X-ray Observatory tried. Both came back with nothing. The breakthrough came from the ground, using a completely different technique. The Gemini North Telescope in Hawaii, equipped with a high-resolution instrument called the Alopaki Speckle Imager, took thousands of extremely short exposure images of Betelgeuse in December 2024. By stacking and processing them, the team reconstructed a sharp view that compensated for the blurring effects of Earth's atmosphere. And there, at exactly the predicted position, was a faint smudge of light that shouldn't have been there. On July 21, 2025, the team, led by Steve Howell of NASA's Ames Research Center, officially announced the probable first direct detection of Betelgeuse's companion star. It has been named Sawarha, meaning her bracelet in Arabic. It orbits at roughly 4 astronomical units from Betelgeuse, closer than the distance between our Sun and Jupiter, and is estimated to be around 1.4 to 1.6 times the mass of our Sun. It is also around 6 magnitudes fainter than Betelgeuse, which is why it hid so effectively for so long. What makes this discovery particularly strange is what Sawarha appears to be, a pre-main sequence star. In other words, while Betelgeuse is a dying giant on the edge of annihilation, its companion may still be in the process of forming. Both condensed from the same cloud of gas around 10 million years ago, but because of their vast difference in mass, they aged at completely different rates. Betelgeuse burned fast and hot and is nearly done. Sawarha has barely started. Sawarha's fate, however, is sealed. Within roughly 10,000 years, Betelgeuse will swell large enough to engulf its companion, and the two stars will merge, potentially accelerating Betelgeuse toward that final explosion. Or Betelgeuse may detonate first, blasting Sawarha free at enormous speed, sending an orphaned star careening through the galaxy. The next opportunity to study Sawarha directly will come in November 2027, when it reaches greatest elongation, its widest apparent separation from Betelgeuse as seen from Earth. Astronomers around the world are already planning those observations. And then there's the rotation problem. Because Betelgeuse found a way to break physics there too. Using the ALMA radio telescope array, 66 antennas working in concert across the Chilean desert, astronomers measured the Doppler shift of radio waves across Betelgeuse's surface. What they found was a textbook rotation signature. One hemisphere shifted toward us, the other shifted away. The calculated rotation speed? Approximately 5 kilometers per second. That number is deeply, fundamentally wrong. And here's why. When a star expands, it slows down, the same way a spinning ice skater slows when she extends her arms. Angular momentum is conserved. If the radius increases dramatically, the spin rate must drop proportionally. If our Sun were to inflate to the size of Betelgeuse, its surface rotation speed would plummet from around 2 kilometers per second to roughly 0.002, nearly a complete standstill. But Betelgeuse appears to be spinning around 2,500 times faster than it should be. Either the laws of physics are wrong, which they aren't, or something extraordinary happened to this star. One hypothesis: Betelgeuse already consumed a companion earlier in its life. A lower mass star spiraling inward and merging with the supergiant would have transferred enormous angular momentum, dramatically spinning it up. Roughly a third of red supergiants are thought to have undergone stellar mergers before their cores collapse, so this isn't far-fetched. The existence of Sawarha today might even be a second chapter of that same story. But in 2024, a team at the Max Planck Institute for Astrophysics proposed a different explanation entirely. Betelgeuse might not actually be rotating that fast. The problem, they argue, is that ALMA's measurements assumed Betelgeuse has a smooth, spherical surface. It doesn't. Betelgeuse's surface is dominated by giant convection cells, massive plumes of boiling gas, rising and sinking, some of them larger than the Sun itself. When these cells move, they produce their own Doppler signatures. A massive upwelling on one side and a downwelling on the other could mimic the pattern of rapid rotation. The team ran 3D simulations of non-rotating red supergiant stars and processed the results through a virtual ALMA. The simulations produced the same rotation signature the real ALMA detected on Betelgeuse, from a star that was, in the simulation, not rotating at all. The boiling surface of Betelgeuse may simply be confusing our instruments. So, is Betelgeuse spinning impossibly fast, or is it an illusion created by its own turbulence? Both possibilities remain live. The answer isn't settled. So where does that leave us? Betelgeuse is dying. That much is certain. At some point, whether in a century, a millennium, or 100,000 years, it will detonate in a supernova that will be visible from Earth in broad daylight. At roughly 700 light-years away, we are well outside the danger zone. The estimated kill radius for a supernova's radiation is around 25 light-years. Betelgeuse is nearly 30 times farther than that. It will be the most spectacular astronomical event in recorded human history. It will not harm us. But what makes Betelgeuse so captivating isn't the explosion itself. It's what the star keeps revealing about how much we still don't understand. Every time astronomers thought they had the answers, Betelgeuse surprised them. A mysterious dimming that turned out to be stellar debris, a hidden companion hiding in plain sight for decades, a rotation rate that either defies stellar evolution or reveals the limits of our telescopes. Pulsation cycles that took generations to begin decoding. We've only been watching this star closely for a generation. A new companion has just been confirmed. Better telescopes are coming online, and Betelgeuse, as always, has no shortage of secrets left to give up. The star on the shoulder of Orion is counting down toward an ending we can't yet predict, and teaching us something new with every tick of the clock.